second for you.
I'm Matthew and Devin behind the camera. Today we'll be talking about the Izod impact tester.
So the sample we're going to be using for this experiment is a piece of steel which is 9.5 millimeters by millimeters, and the groove is 6.5 deep. And the point of the groove is so you'll have a piece of brass material that will go here to lock the material in, so that when the impact tester hits it, it'll be from the top and it's locked into the groove.
So this is the Izod impact tester. Here's the safety pin, the lever, the scale, the pendulum, the weight, and this is where the pieces will be placed in a vise.
Here we're going to be loading our sample. So we start off by loosening this screw here, gently placing material in, make sure that sits flat, and tightening that screw back up. Just make sure it's secured and locked in place. Take the Allen key and tighten it into place. Safety features behind this experiment. This here is a stop to make sure this pendulum doesn't get in the way while you're loading the piece. And another one is that pendulum locks in place before it is released, so to release it you would use the operating lever. And then lastly there's the operating door, which you close when ready to test. Ready to test. So first step is removing the safety pin, moving the operating lever to release, and put it into the number 2 slot.
Put the pin in number 2.
And put the pin in number 2, lift this latch, move the lever to number 2, and as you can see, the pendulum is released.
Don't break it.
Then you lift up the pin, move it to break, and all the way back to number 1.
So the piece was just broken. First you have to move the pendulum out of the way and put stop back up. So as you can see, it didn't fully break through. So you grab the Allen key and loosen the piece up. And this is what the piece looks like after it's done.
So we're going to be reading the yellow scale from here, which is in feet pounds, and from our force measurement we got 45.5 feet pounds. Then we use the scale, making sure 180 is at 0, line it up correctly with where your force pound came up, and from our angle it looks like we got 82.5.
During this experiment, it was observed that steel was the strongest out of the 3 samples that were tested. The steel required a force of 45 foot-pounds to fracture and break. The amount of force needed to break brass was a lot lower. The sample absorbed a lot of kinetic energy when the sample was fractured, because the break shows that it's jagged and uneven. So the steel is very ductile.
189.
So here's some theory behind our experiment. Here's our schematic diagram of a pendulum, and I'm going to go through and describe what everything represents. So R here is the pendulum arm. This box here would represent the pendulum swinging across. The arrows here are going to describe the weight that's being pulled down by the pendulum, also known as gravity. Here's our material, this purple rectangle here, and clearly in here is the notch. Here is where you place the material in the screen box, also known as the vise. Here's the pendulum as it is being swung across. And B here represents angle of rise, and A here represents angle of fall.
So just another reason why the schematic is relative to our experiment on how it's related to the machine itself is the purpose of this experiment is to find the kinetic energy that will create a fracture along the material and continue the fracture as it goes back and forth. Now, what is the purpose of this? Well, quality control purposes would be you can find what the impact toughness of each material is when placing it in certain places, like a bridge or a building. Now, when the kinetic energy hits the material which is at a solid state, the kinetic energy will increase and the potential energy, which was the first energy at initial point at 0, will decrease because the impact will cause it to slow down.
The toughness of steel was tested with a shock impact test. The shock impact test is an experiment now used internationally to determine the hardness of materials and the corresponding toughness with one another.
Through the completion of this experiment, it was determined that steel is a very strong material. The steel sample was still intact when it broke. After the completion of it, it was evident that steel is the most commonly used material in modern construction. It is very durable. It is a very durable material and can be used in a variety of ways. And this concludes our experiment. Thanks for watching.